Okay, so what we're going to do is I'm going to walk through how oil and gas is produced using the simplest site. Nobody builds this anymore, these sites.
I'm walking around a big open field with Dan Zimmerly. The foothills of the Rockies behind us. Scattered about are large storage tanks, oil and gas well pads, and all kinds of weather towers and research equipment.
The last tour I did out here the wind was blowing 60 miles per hour. It wasn't that cold, but man, it was howling. So we stood inside the whole time and talked, and then we were like, okay, let's go out, look, quick, look, go back inside.
Yeah, this is gorgeous.
Dan is part of the Energy Institute at Colorado State University in Fort Collins and is the director of the methane emissions program called METEC. This one-of-a-kind Department of Energy-funded research test site looks for emissions from oil and gas production.
Okay, so I'll give you a tour of the place, but before I start, I need to kind of know where you're starting from. So how many of you know anything about how oil and gas is produced?
What Dan and METEC are doing is testing and analyzing leak detection solutions from companies as a way to reduce emissions at what's called the upstream side of production, where oil and gas get extracted out of the ground.
So if you were at a real wellhead, of course it would be like 4 times the size these days. But what's happening is down 8,000 feet below us, that pipe goes down and turns horizontally. It goes as much as 5 miles horizontally underground. There's been a series of fracturing operations to crack the rock. Despite what you hear on the news, fracking is not new. It's been done since the 1920s. What's new is horizontal drilling. In the past, the way you got oil out of the ground is you had to find a place where it had naturally accumulated under the ground. You drilled into that and there was a reservoir that was very little rock and very much oil. What we can do now with horizontal drilling is to sort of carpet bomb the whole area. They go down and they fan out underground and they go miles, literally miles horizontally underground. Okay?
The use of oil and gas in our society has existed for more than 1,000 years. But it started to really take off in the late 1800s and into the next century. Oil and gas enabled and satisfied our demand for electric power, transportation, plastics, electronics, and many other things. At the same time, improvements in technology made it easier to extract oil and gas and made those products cheaper. Since then, it's played a major role in our economy. What's down in these wells is an amalgamation of ancient organisms that have broken down over millions of years.
It's oil and water and paraffins and tar and everything else that was in the rotting vegetation that formed the oil. So
before a well is drilled, the oil underground is in a high-pressure environment. But once you drill, that pressure, along with the fracking fluids, allows it to flow out of the rocks and cracks.
So when that stuff comes up, it comes up all together. So you have what's called produced water, which is really produced brine. You have the oil product that you would recognize as motor oil is mixed in there. There's heavier stuff, and there's gas. And the gas is captured inside the oil, very much like CO2 is in your soda pop bottle. And when you depressurize that by opening your soda pop bottle, the CO2 flashes off. It flashes out of the liquid and goes into gas phase. Okay? So the whole job of a well pad is to split things up into easier to handle commodities. Okay?
The commodities are things like crude oil, methane, ethane, propane, butane. But entangled with those commodities and produced from the drilling equipment are emissions like nitrogen oxides, volatile organic compounds, and air toxics.
Now, at a production site, the methane release is a tracer for everything else that was traveling with the methane. So chances are pretty good if the methane got out of the system, the ethane, the propane, the butane that was with it in the vessel also got out.
This is why leak detection is important. These are harmful pollutants. Plus, the leaks represent lost revenue for companies. These emissions contribute to both air pollution and climate change. Air pollution is more about what we're breathing now, and climate change is a long-term trend of our planet getting warmer. They're related, but also distinct. Things like methane and carbon dioxide are greenhouse gases and major drivers of global warming. Then there are compounds like air toxics that can impact our health. Air pollution can have both a warming and cooling effect on our climate. Think particulates that can block out heat from the sun. And then there are things like ozone, which forms at the ground level when there is heat and sunlight, causing negative health effects. But high up, ozone protects us from the sun's UV rays. There is a lot of complex science in how our air interacts naturally and with the influx of human-produced emissions. And these emissions come from all kinds of things: farming, landfills, volcanoes. However, oil and gas is a major source. According to the International Energy Agency, the production, transport, and processing of oil and gas contributes around 15% globally to greenhouse gas emissions. Then the use of oil and gas, such as fuel for our cars, results in another 40% of emissions. But to reduce emissions, we have to know specifically where they are coming from.
Originally, the idea of emissions reporting came out of the Clean Air Act. When we started doing greenhouse gas reporting in 2010, the EPA took what they were looking for air toxics and they moved it over to greenhouse gas reporting. The side effect of that was that the reporting program really focused on point source leaks. Okay, so component leaks. So the idea was that you're going to get up close and personal to the leak with your whatever sensor you were using, and you would go kind of fitting by fitting by fitting and look for leaks. So that's the way the whole program is designed. And then for anything that wasn't a component leak, it was a process emission. And if you look closely at what EPA has for reporting, all of those are calculated. They're not measured. So unsurprisingly, the inventory method was sort of hopping around on one foot. And it has been for a long time. And the Clean Air Act constrains what EPA can do, and all the states just copy EPA.
We have general estimates about emissions to the atmosphere, but pinpointing exact amounts and from where can be challenging. When we were at METEC, 9 technologies from 8 companies were being tested on site.
So what we do is we evaluate 3 things. The first one is, did they detect the emitter? The second thing we want to know is how close did they get to the actual location of the leak when they predicted one? Did this sensor say that the emitter was on the tank when it was actually on the wellhead? Or did they just say, it's someplace on the well pad? And then the third thing is, how good were they on their quantification of the emissions? So if they said it was 5 kilograms per hour, was it 5 or was it 2 or was it 10, right? Makes sense?
Dan and his team consider themselves a trusted third party. They're researchers, and they will work with anybody, whether that's a government entity or a business. But he tells me, you're getting the same honest answer, even if you don't like it.
The big thing to know about the production here in Colorado is that it's not just finding leaks, it's getting rid of the opportunity of leaks. The producers here are making major strides in the way they design their well pads, so that the opportunity for emissions from it have gone way, way down. If you look at like this well pad, this mock-up here, this is like comically simple compared to what is operating in the basin today.
Back in 2014, Colorado was the first state in the U.S. to adopt regulations on methane from oil and gas. That's why industries that operate here have to step up their game in identifying where emissions are coming from and try to stop them. So what's happening in the oil and gas industry today? How is it being regulated? What actions are companies taking to reduce emissions? And how do we know progress is happening? My name is Kristan Uhlenbrock, and from the Institute for Science and Policy, this is Clearing the Air, the Hazy Future of Our Skies, an 8-part series about the state of air in Colorado and how we are navigating this complex problem that knows no borders.
In Colorado, we believe, because of the heavy regulatory environment and just how we work and how we work in proximity to our communities, we produce some of the cleanest molecules of energy in the world. We're very proud of that. My name is Tricia Woodward, and I am the Senior Director of Regulatory Affairs for the Colorado Oil and Gas Association, also known as COGA. I'm an environmental engineer. I have over 23 years of experience in environmental protections. I've worked as a civil engineer, I've worked in mining, I've worked in rapid response for EPA, but I've spent the last 12 years of my career in oil and gas, mainly doing air quality work.
COGA has been around since 1984. They advocate on behalf of more than 200 members, as well as inform them about policies and economic trends.
If you're leaking natural gas instead of selling it, that's not a good practice. That's not going to make you money. And so emission reductions are really about us keeping it in the pipe and getting it to market.
Colorado is the 5th largest oil-producing state in the country. And oil and gas extraction accounts for $16.5 billion, or less than 5%, of the state's GDP in 2022, according to the Bureau of Economic Analysis. It's also about 1% of jobs in the state, according to the Department of Local Affairs. The state's economy benefits from keeping the industry running. But all of us have a vested interest in reducing emissions, which has economic and social cost to our health and environment. In recent years, there's been a significant effort to pass legislation and codify regulations that hold oil and gas operators to a higher standard than they might face elsewhere.
I've been at COGA for a little over 5 years now. I actually just finished my 27th rulemaking for the oil and gas industry in that time. One of the first that I've participated in was in February of 2021. We did a rulemaking on controlling pneumatic devices at the Air Quality Control Commission.
Pneumatic devices are things like valves that can be one of the largest sources of methane leaks at production sites.
We spent hundreds of hours in conversations with environmental partners, local governments, to really hear from them what it is they're looking for and what would be satisfactory to them. And then industry was able to come to the table and make that happen. Not everybody always gets what they want, but I think we can always find common ground. And we strive literally every single time we do a rulemaking to meet with those organizations and see if we can hear out all stakeholders so that we can come to the table and get their concerns addressed.
While there are examples of diverse interests reaching an agreement, the process isn't always easy, nor does it always work out. And as Colorado's political landscape has changed, there has been a greater appetite for environmental regulation. That's brought fresh challenges for the industry.
The state will say, okay, just do this for everything, but that's not always the best way. You know, some operators might get emission reductions from pneumatics, some might get it from tanks, so they can get more bang for their buck if they look at this creative process. That's harder to write in a rule.
Christy has concerns that the speed of those changes will disrupt businesses' workflows and make doing business in Colorado too unpredictable or expensive for oil and gas operations. She gives the example of permitting, which was overhauled in 2019 with the passage of Senate Bill 181.
It's really important for us that we were able to have a consistent expectation of the time frame that's required to get permits. And right now, with the rules changing and some of the policies changing, that process has really been upended. And we don't have a lot of certainty around the timing for that or what's required or what should be submitted, what would be sufficient for approval. So we're all kind of learning together. I think I would prefer to have seen more stakeholdering, more process and thought from all entities involved go into that process. Small businesses, I do think, are struggling with this regulatory environment. It's just impossible to keep up on it and know what's going on, what you're supposed to be doing. And so we try to support those folks as much as we can as well to make sure that we have a healthy industry here.
In addition to reducing emissions from oil and gas production, Colorado is also focused on transitioning to new energy sources. Christy sees a lot of folks in oil and gas who are open to trying new things.
Someone told me this morning, no one's writing me a check for geothermal energy right now, but they're writing me a check for oil and gas. So I want to transition into that, and I want to look into that, but it has to be economically viable and manageable.
One challenge with the energy transition is the need for both baseload power and what's called dispatchable energy, or energy that can be turned on and off at the flick of a switch. Because solar and wind are variable sources of energy, they aren't always there to turn on. So they have to be accompanied with things like batteries to store the power. Hydro, coal, nuclear, and gas have often been the solution for that need to supply consistent, reliable power. As we transition to a net zero energy system, there are lots of technologies competing to lower our carbon footprint while still supplying steady, reliable energy. Because people don't want their power to go out.
I think geothermal, hydrogen, and CCUS is that dispatchable or reliable future. I think that those are all drilling with holes in the ground, which is what we do best. I think when you look to other sources, large manufacturing, for example, of emissions that are large, they will need those types of technologies to help lower their emissions. So it's definitely a wave of the future. There does need to be some movement and political will to make that happen in Colorado. It's happening a lot faster in the states around us. And it makes me a little concerned that we're going to become an energy donut or an energy suck, and everyone will just kind of work that around us if we don't create a regulatory pathway for those types of projects to happen here. The Energy Information Authority says that you will need more energy. The world will need more energy as we move forward, and Colorado's no exception to that, right? So if our population grows, we need additional electrification, and there's no genie behind the light switch, right? You have to get that energy from somewhere. And other states, if they're looking at carbon sequestration and producing that energy, can provide it to Colorado. But if we're not providing it here, then what are we doing? And if they can do it because they have a pathway to sequestration and create that reliable power, you'll start seeing that coming out of Wyoming, Utah, New Mexico, and we'll be using that energy, but we won't be producing it anymore.
Because the demand for energy isn't going away, the question that lingers is, what will provide the energy source for the future? There's a difficult dance here. The speed to clean up operations, the transition to new innovation, the limitations of business models, and the need to protect the health of each other and our planet.
We're looking at the CO2 pipeline construction that will deliver CO2 that we're capturing from our central treating facility heading west, and will eventually connect in with a big CO2 pipeline called the Cortez Pipeline that delivers CO2 to West Texas.
I'm within the patchwork boundaries of the Southern Ute Nation, located in the southwest corner of Colorado, not far from New Mexico. And I'm standing in a field with a trench cut through it. A silver pipe, about the diameter of a basketball, lies next to it. I'm speaking with Coy Bryant.
The start of the pipeline is actually due east of here, what we call our Arkansas Loop Central Treating Facility. And that's where we remove the CO2 from the natural gas and where we'll capture it and then compress it and send it down this pipeline. It's mostly on tribal land. This section here in the Animas Valley is private. And so once we get kind of west of here, then we'll be on tribal land.
Coy is the president and COO of Red Cedar Gathering, a midstream energy partnership between the tribe and Kinder Morgan. He also runs Aka Energy Group, a Southern Ute company focused on net zero power generation. The CO2 pipeline is for the Coyote Clean Power Project, which Aka Energy Group is collaborating on with another company, 8 Rivers Capital.
8 Rivers Capital invented a technology. It's a power cycle process. And what it does is it uses oxygen instead of air to combust with methane. And in that process, the byproducts are CO2 and water. And so you inherently, through this process, capture the CO2, and you're able to spin a turbine with high pressure supercritical CO2. It's a first of its kind turbine. And you generate electricity. And since you're continuously producing CO2, you need a way to send off the excess CO2.
Currently, this technology is in a demonstration phase. Koi is queuing up for the commercialization. Eventually, the pipeline will take the captured CO2 to West Texas, where the intent is to store it in the ground. One of the big concerns around carbon capture, utilization, and storage, or CCUS, is that CO2 could be used for enhanced oil recovery. This means that CO2 gets pumped into mature oil sites and helps the oil flow more easily.
Our project we won't use that CO2 for enhanced oil recovery. It will be sequestered.
Once the Coyote Clean Power Plant is built, it will generate 280 megawatts of net zero power using natural gas. Because Colorado has set a goal of 100% clean electricity generation by 2040, utilities will need to source clean power. But there is a hesitancy from some utilities to buy power from natural gas plants, considering it's still a fossil fuel. There is still a need, however, for consistent baseload power, which in some areas is difficult with the current renewable and battery technology. So Koi is betting that this project will fill that need. The Coyote project has filed for interconnection to the grid so that once they start generating power, they should have buyers. He's hoping this sort of investment will bode well for both the environmental interests of the Southern Ute and their long-term business strategy.
Not everywhere in the country will you have good solar resources or wind resources, but you may have good natural gas resources like we have here. And so trying to put a square peg in a round hole and say, well, we have to force fit a solar or a wind project in an area where there aren't good resources doesn't really make sense. We feel we can do fossil fuel development responsibly. When I think of the energy transition, everyone automatically assumes that means renewables. And really picking winners and losers on technology is not really the right way to go about it. And I think what I find myself doing is trying to educate people on, we're trying to control emissions. That can be through renewables, but it can also be through responsible natural gas production and use. And there's ways to do it, and companies are committed to do it. The tribe is absolutely committed to do it. And the key thing is emissions. It shouldn't be what the source is. When you think about climate change and greenhouse gas emissions, that's what you need to control. And so if you can do that using fossil fuels, we should, where there's an abundant resource like there is here. When you think about investing, the tribe, again, has abundant natural gas resources, so they should be able to utilize those if they choose to build projects that'll be decades long and add to the benefit of their membership for generations.
From Koi's perspective, he views emissions reductions as just part of the way they operate, because compliance is good for both the environment and business.
We want to keep gas in the pipe. That's how we make money. That's why we're in business. And so we have a really tight monitoring system, 24/7 type of system. We have really good measurement. And so we can tell where we have potential issues, and then we can always go out and find those and fix them if they need to be fixed. So it's very, very important to us on both fronts, from the business side and from the compliance side. The benefit of energy to the tribe, it's substantial. It's a very big benefit to the tribe. And so being able to utilize those natural gas resources in power development, in addition to what they're currently doing, is a really good long-term approach for them to utilize their resources and exercise their self-determination.
In addition to clean energy as a business interest, the Southern Ute tribe is unique because of their air quality program. They are the only sovereign Indian nation in the U.S. to have received the authority from EPA to regulate their emissions under Title V of the Clean Air Act. The Title V section is about the permitting of stationary sources based on the amount of emissions they release.
The tribe's got a really old air program.
Here is Danny Powers. Danny leads the air quality program for the Southern Ute. He's telling me about the history of how the air program came to be.
It was started in 1981 by the late Mr. Michael Frost, who at the time was the environmental programs director. And at that time, there was no ambient air monitoring going on the reservation, and he wanted to know what those air levels were because he had concerns. There was some large power plants in New Mexico south of here, and there was also the oil and gas industry was taking off here. So he started obtaining EPA grants to do ambient air monitoring. And by the mid-'80s, he was trying to get air quality jurisdiction on the reservation, and he was working with the state to get into a memorandum of understanding. They weren't really going for it because there was a 1984 public law that reestablished the reservation boundaries and in some way had limited the tribe's jurisdictional authority over non-Indian owned lands, because Southern Ute Reservation is what's often referred to as checkerboard, in that there's not only tribal owned land, but there's privately held non-Indian owned land within the boundaries.
Michael Frost was unsuccessful in convincing the state of Colorado to hand jurisdiction over to the tribe, until 1990, when amendments were made to the Clean Air Act.
That tribal authority rule provided tribes with the authority to regulate air quality for all lands within their reservation boundaries, including non-Indian owned lands.
This new rule initiated a back-and-forth negotiation between the tribe and the state of Colorado.
To avoid litigation, the tribe and the state at that point agreed to collaborate on air quality, and that led to an intergovernmental agreement.
This agreement was reached in 1998 and stood up a commission with both tribal and state representatives. However, it wasn't until 2012 that it was enacted into federal law.
It's really significant because it provided the tribe with jurisdiction over all lands within the reservation boundaries. That from a tribal self-governance standpoint is really important.
The history of tribal sovereignty in the U.S. is long and complicated, with tribes often being ignored or excluded from systems of governing. And a tribe's ability to provide for their people, both economically and environmentally, can be challenging due to the damaging legacy of the historical treatment of tribes and indigenous people by the U.S. government, leaving many with limited resources. In addition to exercising tribal sovereignty, the designation allows the Southern Ute to be treated like a state and target sources of air emissions to ensure compliance. They also have the authority to impose more stringent regulations than EPA. So once they had the legal authority, they started identifying and reaching out to operators within their jurisdiction.
We made contact with those folks, and I wouldn't say they all agreed that they were under our jurisdiction, that's for sure. A lot of those operators are not within Colorado, and they might only own a couple sources, and they're on privately owned land, and it was a real shock to them to hear that they're under the tribe's jurisdiction. So we had to build those relationships with them.
In 2012, there were 42 major sources operating on the Southern Ute Reservation, which equated to a third of all major sources in Indian country across the U.S.
Nobody actually knew the exact numbers of sources on the reservation as far as oil and gas goes, or what their emission contributions were. And at that time, we undertook a project of quantifying emissions from all of the oil and gas sources on the reservation, and we've done that 3 times now. We started doing civil enforcement actions in 2015, and I think at this point we've settled just under 50 civil enforcement cases and close to $2 million in civil penalty money, which goes to the tribe. We've seen a real improvement in compliance here since we took over the program, and I think that was kind of a result of EPA's resources just not allowing them to have as good of a presence down here doing inspections. And I think some of the operators that had worked on the reservation for years, they weren't used to anybody looking so closely at their air permits.
Today, the tribe currently regulates 33 major sources. This is approximately 13% of all the major sources within the state of Colorado. To put that into perspective, the Southern Ute boundary comprises only 1% of the total land in Colorado. And now, Danny and his team are pursuing authority to regulate minor sources, which would include about 300 additional sources of emissions. Collecting high-quality data is important in the region, both for regulating sources within the reservation and to provide data to the broader community on poor air quality days.
It's really noisy inside, so if you want to ask any questions.
Is it noisy inside here?
Yeah.
Okay, cool.
So any questions you have, probably you want to ask out here.
Okay, let me...
The Southern Ute Air Program has 3 air monitors across the area. I'm at the Ute 1 station in the town of Ignacio. This is where the majority of people and businesses are located.
This is the meteorologic tower where we collect that data. And this right here is the monitoring shelter to our left, which has all the instruments in it.
I'm with Danny and his 2 colleagues, Jacob and John, who do the technical work to keep the air monitors operating.
This is our meteorological tower. It's 30 feet tall. On it, we've got, at the very top, it's a wind anemometer. Then the next thing next to it, that's our relative humidity sensor.
Creating long-term, high-quality data sets is vital to know what's happening over time with the air. And while ozone levels in southwestern Colorado are currently meeting the federal standard, there are many types of air-related health concerns. The big one is wildfire smoke, blasting particulates across the sky, and also the arid climate.
There was a very large dust event during the spring, wind blowing dust from Arizona, Utah, western Colorado got blown through here, and we had very high levels of particulate matter. It was reading as hazardous. And actually during those days, I mean, you could walk outside and you could smell it, you could see it. It was very obvious, but we were able to get an alert out for people.
I thought it had kind of like an earthy smell to it. The biggest thing I remember about it is being able to like physically feel it. I could feel it like gritting in my teeth and in my eyes if I didn't have sunglasses on or something. So that was just like kind of extreme.
Jacob, John, and Danny tell me that they do this work because they care about the community, both within the tribal lands as well as the broader region.
I grew up in this community, and I care a lot about it, and I think I like being able to play a role in providing what I see as a really valuable public service in providing this data to the public, and so people can take measures to keep themselves healthy. And I guess I'd add that the tribe really is the only agency in this area that's doing air quality monitoring. The state does a little bit outside of the reservation boundaries, but not extensively. And there's some in New Mexico, but we really are covering this community, and it's a great service that the tribe provides.
Data is an important theme when talking about air quality, because better data can help with better decisions. But to get there, you need the resources and the right systems in place.
One of the first things I did, actually 9 days after I started, went before the Joint Budget Committee and requested significant funding and resources from the Colorado legislature.
This is Michael Ogletree. He leads the Air Quality Control Division at the Colorado Department of Public Health and Environment.
So in the past 12 months now, we've very quickly have been able to hire about 146 FTE. That's close to doubling the size of the division when I started, which was about 195.
The hiring blitz that Michael went on has set up the division to support implementing all of the policy changes over the past few years. One very important area they're working to improve is the hurdles in collecting and standardizing data.
Some of the different reporting requirements are still hand delivered in paper. We scan them. We then upload the data by hand, and then we have to rescan them to go into another system. So some of those are just very cumbersome. And so through a digital process, we'd be able to better ensure that mistakes and errors aren't made, and also allow us to better analyze the data.
I shouldn't be surprised that scanning still exists in parts of government, but it does. Michael tells me about Colorado Regulation 7 as a way to demonstrate how data collection can achieve better emissions reduction. Regulation 7 requires a new standard for oil and gas to limit methane emissions as well as ozone precursors.
It was required that sources do 10 days pre-production monitoring, and then all through the pre-production phase, and then about 60 days into production. So by monitoring during that time period, we'd have a better understanding of what types of emissions are released from those sites, and more importantly, as part of that rule, have a requirement for sources to very quickly address some of those leaks. That data didn't have a standardized format, and that's made it challenging to kind of analyze the data. We've worked with the contractor to untangle that and do that analysis, but going forward, we need to come up with a way to standardize that data, and it's something we at the division have been working on, and hopefully we'll have a data standard by the end of this calendar year.
Numbers on a spreadsheet don't always seem exciting, but how can we measure progress without having good baselines? Standardizing and merging data sets can help get a better picture of emissions in the state. These analyses help the division identify and prioritize what needs to be better regulated. And what they're learning right now might have a ripple effect beyond Colorado.
For oil and gas regulations, we have the strongest in the nation and perhaps in the world. EPA is looking at the rules that we have here in terms of oil and gas regulations and adopting some of those for wider scale use across the U.S. It's my goal to continue being a leader in that space, and through engagements with some of these regional entities, not only leading the way, but sharing with those entities how we do our work and different ways they can collaborate as we work towards some of these more challenging areas of air quality.
One of the challenges that Michael and his team face is the big uptick in organizations and individuals gathering data beyond the businesses that have to in order to get a permit to operate.
I think as more entities who are collecting data are sharing that information with us, we need to have some of those conversations more broadly about what type of data they're collecting and how we can use it. In terms of who's collecting data, anywhere from the backyard user, there's a handful of environmental groups who are using and collecting data. There are other local entities collecting data. There are research organizations collecting data, and all of it has a use. And I think as we think about a data standard, having parts of that identify and classify the different types of data so that we are very transparent in how we can and can't use different data sets that are coming through.
Standardized data that's collected and shared in real time could help all of us stay informed of air quality events, whether it's high ozone days or dangerous leaks. For example, Michael says there are about 6 different entities collecting air quality data in and around Suncor's Commerce City facility.
If we had a system where we have all the data in one place, it would allow us to do automated alerts to make sure that we can be as quick as we can in getting that information out to communities so they know what's going on and can potentially find ways to protect themselves from that air pollution.
Information is power. It tells companies when they have a leak to fix, which can save them money and keep them in compliance. It tells the government when there's a problem that needs to be solved. And it tells the rest of us whether or not it's safe to go outside. Up next, we hear from communities across the state that are working to collect data and collaborate on solutions to better our air.
The City of Pueblo, we'll be working with them on a grant that we received from the EPA. It's important to think about what you want to do with the data and what you want to do with the project at the beginning so that we don't collect a bunch of data and then think about what you want to do.
Laws of Notion is a production of the Institute for Science and Policy at the Denver Museum of Nature and Science. To learn more, visit clearingtheair.org. I'm your host, Kristan Uhlenbrock. This episode was written by me and Meredith Sell and produced by Tricia Waddell, with help from Nicole Delaney and fact-checking by Kate Long. Sound design by Seth Samuel, with tracks from Epidemic Sounds, and audio support by Jesse Boynton. For a full list of credits, check out the show notes. If you learned something new, please rate, review, and share the podcast. Thank you for listening. See you next time.